humans ever did touch down on Mars, how would we survive? Not the kind of question that the soil scientist gets asked, is it? I mean, we study Earth on Earth, don't we? But that's where you'd be wrong.
T-minus 10, 9, 8, 7, 6.
I've been speaking to Dr. Daniel Batcheldor, the head of the Physics and Space Sciences at the Florida Institute of Technology. Working with the Kennedy Space Center, Daniel is currently travelling around the Earth in search for materials that may simulate the Martian surface. So, could a life on the red planet really come down to the production of quality soil?
Getting ourselves to Mars, I think, is the greatest human endeavour in the history of our species, or the future of our species, if you like. And I think if we can figure out how to live on Mars, then we'll be able to actually start to figure out how to live on Earth, because I don't think we're very good at living on Earth right now. We don't have a very good sense of sustainability in our current society, and I think if we figure out how to create a sustainable colony on Mars, we're really going to improve quality of life back here on Earth.
Well, that's absolutely great, because one of the things soil scientists love the fact is that this is a planet named perhaps after the soil, and this is planet Earth. So the question really is if we're thinking about soil on Earth, why go to Mars? What is there on Mars to discover for soil science back here in planet Earth?
Well, we've seen through history, particularly the history of science, astronomy and planetary science, that by being able to compare planets through our solar system, we actually learn a lot about Earth itself. And so understanding how Mars has evolved as a planet will help us understand how Earth could evolve as a planet if we don't pay particular attention to it. Now, in terms of the soil, the relative content of the soil on Earth could end up like the current soil on Mars. But the soil on Mars right now, it's not really soil, we call it regolith, because it doesn't have any biological material in it. And so being able to understand how we can process the regolith we find on Mars to help plants grow in it once we get a colony on the surface of Mars could help us understand how we can help mitigate some of the issues that we're having currently with soil here on Earth.
We know that on Earth, generating quality soil usually involves using organic material and incorporating that with mineral material in our soil profiles. Is that the kind of thing that perhaps in the future we can try to do on Mars?
Yes, absolutely. And I will state for the record that I'm outside of my field of expertise as an astrophysicist here. In terms of the research that we're doing to address how to evolve Martian regolith into a soil, that is something that we are looking at. So we do know that the plants require a good amount of nutrient supplements into the water that they're using whilst they are growing. But we are also carrying on experiments to see how the regolith simulants we're using change as generations of plants are grown and harvested. So we're keeping the regolith simulant that we're using. We're not throwing it away, and we're continuing to grow new generations of plants as the biomaterial from previous root systems actually builds up in that soil. And so we don't yet have any publishable results from that, because we're going to have to wait quite a few, potentially even years, before we see a significant difference in that. But yes, we are trying to reproduce what we presumed happened here on Earth, which is as more and more plant material grew and died, the actual composition of soil changed and became more favorable to larger and more nutrient-rich plants growing.
So have previous missions to Mars ever really considered the possibility of soil or life in soil, or have they been more interested in finding water perhaps?
Well, the two things go hand in hand. And so the first NASA missions to the surface of Mars to successfully get there, the Viking missions, their mission was to look for signs of life. And since then, as our understanding of Mars has developed with more and more sophisticated instrumentation, better and better data from the surface directly, better and better data from orbit, and from facilities here back on Earth, particularly the Hubble Space Telescope, we've actually seen now that just randomly landing on the surface of Mars is not necessarily going to be the best way to find evidence of previous life. We're fairly sure that there's no current life on Mars, but if we were to dig down a few centimeters perhaps, or maybe a meter or so, and actually look at the subsurface conditions on Mars, it may well be that there is liquid water down there, and it could potentially be somewhere where life has evolved independently of Earth, or maybe there's still some evidence of there being active life there, but we're really speculating on that now. But what we do know, and what NASA has been doing for the past decades, is following the water.
And you're not necessarily following the water on Mars, but you're following around Earth at the moment, finding materials that may simulate the Martian environment. Where kind of have you been on Earth, and what have you found out?
So on Earth, we do expect there to be a similar composition in the most abundant elements that we find. Earth and Mars are both planets that are relatively close to one another in terms of distance from the Sun. They are planets that formed in the same solar system at the same time from the same material. And so the silicon, oxygen, iron and magnesium that we find here on Earth, we also find on Mars. And that's not a coincidence. That's a result of the planet formation process in our solar system. And so we do expect to be able to go out on Earth and find regions of Earth that are fairly similar to particular places on the surface of Mars. Now, Mars is a relatively dry planet. It's low humidity. It's got very thin atmosphere, and it's very cold. And so we like to find here on Earth high altitude, low humidity, cold places. One good example is the Atacama Desert in Chile, where we do have samples of regolith simulant from. But there are also other places around the world, Hawaii, the summit of Mauna Kea on Hawaii, for example, and then various deserts throughout the United States. And we're now trying to get some samples back from some colleagues in Australia, which is, of course, if you just look at the classic pictures of Ayers Rock, you know that the surface materials in the outback are red. I've spoken with astronauts who say when they've been in orbit over the outback, they say, yeah, this is what they think Mars would look like.
And finally, Daniel, is this something that a soil scientist who's just coming up through the ranks of their academic career, is this something that they could perhaps inspire to be? I mean, to be a soil scientist, not thinking about soil on Earth, but maybe soil on other planets?
Absolutely. I think there are so many exciting career paths that are to do with our mission to get people sustainably and safely onto the surface of Mars. A mission to Mars is a huge and exciting undertaking that's going to involve people from around the world, not just in science, engineering, mathematics, and technology, but also in business and also in psychology. I mean, the cost of getting there is going to be something we need to figure out. We need to figure out how to pay for it, and we need to figure out how to deal with the psychology of a crew that's going to be in such a high risk situation with literally no chance of rescue if something goes horribly wrong. And so indeed, there's a lot of research that needs to go into how Martian regolith is going to be used as a growth substrate for generations and generations of plants in the future, and that's a very rich area of research. And we now see calls from NASA asking for researchers to propose to them for funding to do this type of research. And so yes, budding soil scientists can now really start to expand their ambitions out into the solar system to ask that question of, can we make a soil out of Martian regolith?
Fantastic. Thank you, Daniel, and I wish you all the very best for your work in the future. And if people want to find out a little bit more information about this, where can they find this information?
I regularly post on Twitter at Dan Batcheldor, and then of course we are keeping our research up to date on our website over at Florida Institute of Technology. So just by following me on Twitter and checking out our website at www.fit.edu, people will be able to find out a little bit more information about what we're doing over here.